Okay, so this is the graph I drew for this question. So the car will experience three different forces, which is the friction, normal force, and gravity. And let's consider the xy coordinate here is the positive direction on a horizontal direction and a vertical direction. So therefore, if we decompose the normal force and friction, we'll have Fx and Fy, Ny and Nx. So Fx is the x component of friction, and Fy is the y component of friction. And Ny here is the y components of the normal force, and Nx here is the x components of the normal force. So therefore, if you can tell that, so the centrifugal force here, which is mv squared over r, should be equal to the x components of the normal force plus the x component of friction, okay, which is n sine theta plus f cosine theta. So we know that Ny is equal to Fy plus mg, okay, because along the vertical direction, Ny is going upward and Fy and mg is going downward, and the net force between them should be equal to 0 since the car didn't move up and down, okay? So therefore we have Ny is equal to Fy plus mg. If we move Fy plus mg to the left side, we have Ny minus Fy minus mg is equal to 0. So we know Ny can be equal to n cosine theta, Fy can be equal to f sine theta. So therefore we have n cosine theta minus f sine theta minus mg is equal to 0. If we do some arrangement here, we have n, which is the normal force, is equal to mg plus f sine theta over cosine theta. So remember here we have n sine theta plus f cosine theta. So now let's plug in back to the equation. So we have mv squared over r is equal to mg plus f sine theta over cosine theta times sine theta plus f cosine theta. Therefore, we have mv squared over r is equal to mg plus f sine theta times tangent theta, and then plus f cosine theta. So therefore, we have friction is equal to m times v squared over r minus g tangent theta over sine theta tangent theta plus cosine theta. So we know the mass of the car is 1,050 kilograms, and the speed of the car is given as 85 kilometer per hour. If we convert it to meter per second, it's about 23.61 meter per second. And we know the radius is 72 meter, and the acceleration of gravity is 9.8 meter per second squared. And the angle here is given as 14 degrees Celsius. So therefore, let's try to determine the friction. So the friction is, can be equal to, let me see, 1050 kilograms and times 23.61 meter per second, and then square over r, which is 72 meter, and then minus g tangent theta, which is 9.8 meter per second square, times tangent 14 degree, and this thing here over sine theta tangent theta plus cosine theta, which is sine 14 degree times tangent 14 degree, and then plus cosine 14 degree. And this will give us the friction is about 5398 Newton. So this is the necessary friction that will be applied to this case, okay? And the direction of the friction should be down the plane. Remember the xy plane? So if it's down plane, it should be something like this. Say down the plane. Well, why is that? Well, it's because the frictional force is required for rounding the curve at a given speed of the car, okay? So the direction of the friction must be down the plane, okay? So therefore, these are the answers for this question.